I'm the tech lead for the Yahoo Finance Android application. And let's start with the show of hands here. So how many guys have applications on the Play Store? All right, not unexpected. Keep the hands up, keep the hands up. How many of you guys here think your app start up fast? Okay. And well, all right, I was going to ask if you guys are confident that as you keep iterating and adding more and more features. Okay, yeah. So I was going to ask if you people are confident that as you keep building, as you keep iterating. Not a part of the So as you keep iterating, the app tends to stay fast. So that's what we're going to talk about today. So we're going to talk about how you can iterate fast, not worry about keeping the app, not concentrating on keeping the app fast because you've automated everything. So you can continue doing whatever you're good at. Okay, so users want the app to be fast, right? They have a lot of choice. You need to convince them that it's actually worth their time. So 20% users, they expect the app to start up really fast. And after that, they're very quick to judge you guys. So if the app is slow, then that's a reflection on the performance of the company. And if I plug my thing in. So going forward, after that, they don't hesitate. They're ruthless. They don't hesitate to actually uninstall the application if they think it's not doing all that well. So, it's a pretty big thing here. Now, we know they really want fast, but then, sorry, just give me a second. Let me start this up. Yeah. Okay. But then what's fast enough? It's a very difficult question to answer, but there's a lot of research. And we've seen that 53% users actually drop off if a mobile page takes more than 3 seconds to load. So when I was doing a dry run and I ran this off people, they thought it was bullshit. So I actually put up the reference up there. And so it says something. The other thing is also that the top 40 apps on the Play Store, they actually take less than 2 seconds to load. So there's a trend here. Not probably a causation, but a little bit of a correlation. So we know they want fast, but if you actually go to a user and ask a user, you want an app to start up fast, but you know what actually fast is, then you might not actually be able to get a very crisp answer. Will they be okay if your application object is instantiated and starts up? The answer very likely is no, because you still don't have a UI. What about an activity? You have an activity. Imagine you did your set content view. You have your layout up there. Will that suffice? I would still say no, because you are looking at an empty screen, which probably doesn't add any value. Now, a lot of performance analysis services out there actually use a bunch of heuristics. Things like, are there spinners showing on the screen? Things like, has the activity loaded up? Or all the draw phase is done. Based on that, they say, okay, we've now cold started. But I don't think that suffices. So I would say that you actually need to load some data up, useful data, for the user to say, oh, okay, I tapped on this icon and I now have what I want. So let's look at a couple of applications to think about this a little more, right? We're looking at Facebook here. A user taps on the app opens up, the icons on top load up, and a little later the news feed loads up. So I'm sure Facebook would have done a lot of research. You should go talk to them. But I would think that the news feed has to load up before users say, okay, now I can see. I have what I need. Let's look at another application, Macy's. So you tap on the icon, a little bit of waiting, the hero loads up, the element on top, and then after a little bit, the sections on the bottom load up. Maybe it says that users care more for the hero on the top. Bear with me as we look at the last application. This is IMDb. It's a little more complicated. They load up 2 sections, and then they take their time to load the section in the middle. So, what's the takeaway here? The takeaway is it's very difficult to figure out what users want when the application starts up. And that's for you guys to decide. So you have to go figure out what your most important pixel on the screen is. The thing is, very likely you already know the answer to this question because it's very likely baked into the design of your UI. So you have to talk to whoever it is, your VP, your CEO, your designer, and find out an answer to that question. Now, if you don't have an answer to that question, it's probably a little bit of time for you to go back and introspect. Figure out when your user taps on the application and the app comes up, what do they want first? So we're looking at the Yahoo Finance application here. We actually went through this whole process ourselves. Now on the screen here, so a little bit of an intro about the application. You can open up the application, you can do a couple of things. You can look at the health of the financial markets. Here we're looking at a section on top which tells us how the Dow, S&P, and Nasdaq are doing. And we have another section where a user can go out and actually identify some companies that are interesting to the user and place them in a list that they want to watch, something like a bookmark. So we asked ourselves, okay, what should we load first? What should we prioritize? And it turns out that users care for the companies that they told us they care for more than the health of the market. This is kind of understood. We got all this information by user analytics, by the way. So your taps and touches and things like this. And we've also seen that it doesn't suffice if we just load up all the companies. We actually have to go out and load the latest market prices as well. So then our definition of cold start is load up whatever the user wants, which is, in this case, the watch list. Load up all the prices. And there we have something that the user will probably use. So now the definition of cold start is something along these lines. A user taps on the icon and then the user gets something useful because very likely they come in, they tap, and they'll possibly exit. You have to give them something useful. Using all this information, let's now try and come up with a goal for ourselves. So before we get into that, I'll just take a step back and again talk about what we're trying to achieve here. We don't want you guys to actually have to worry about starting up fast every time. So let's try and come up with a goal that a machine can understand, and let's try and automate the process. So as you keep developing, there's a higher chance that you're able to still stay within this goal. So based on the numbers that we saw earlier, I think it would be a good target, 2000 milliseconds, which the top 40 apps take to start up, would be a good starting point. So let's say on production, across all our users, the app should start up in 2000 milliseconds and show something useful. But then you're talking about a lot of users. So the distribution of cold start typically tends to look like this. This is a histogram of all the startup times. And you see that there's a very, very, very long tail. This, this is just how it works. We've seen this consistently. And what we want to do is identify the hump. I don't know if you can see the pointer. There's a hump in the middle. What we want to do is take all the users to the left side of this hump, which is more than our 50th percentile, and try and optimize the experience for them. And this number is the median right there in the middle. So let's go back and say we want our median cold start to be 2000 milliseconds on production. Okay. But then you have a lot of devices. You have to figure out what you want to do. There's a variable again. And what we've seen is that on the top 3, 4, 5 devices, performance is usually negatively correlated to the popularity of the device. So your most popular device is likely the worst performing device when it comes to cold start, because people don't just go out and buy new devices as they come out. And also, there's a lot of variance over networks. People are over LTE, people are over Wi-Fi, HSPA, and we've seen that as we vary across networks, there's a lot of variance. You have to figure out what you want to do. So our goal could look something like this. We could say, okay, across all startups of all users on production, we want the median cold start to be 2000 milliseconds. So I'm saying this is a starting point. You guys have to go through this exercise yourself. You have to figure out what it means for you. Okay, so now we have a goal. Let's talk about what we can do with this. So actually, before we get to that, our goal is just not this. Like I've been talking about this for quite some time now. So we want to reduce the amount of effort that we put in, which means that we have to maximize our the benefit that we derive from any of the effort that we put in, which means that as we go out and analyze our cold start time, we have to find the lowest hanging fruits and try to address those first. So as we talk through this, I'm going to identify some of those things that we identified in our code. These are probably takeaways for you guys. The other thing that we need to do is stay consistently fast, because once your application starts up fast, you've upped the bar for yourself. So you've not really done yourself a favor, because if you slow down, then people are going to come back and judge the app again. So once you're fast, you can only become faster. And we need to automate all this. Like, this is the central theme of the talk. You don't want to invest a big percentage of your development time into making sure that the app starts up fast. Should I have hit that button? Oh. I'm gonna do that now. I don't know what this means for all the guys watching this on live stream. Sorry for the $60 that you paid. Okay, so coming back. Let's try and come up with a concrete plan. So we're going to be talking about two sets of things today. The first set of things is automate, automate, automate. We'll try and figure out what your definition is. We've already come up with a definition, but we'll try and look at some code patterns. And we'll see what we can actually, we'll see how we can collect all this data. We'll see how we can make sense out of it. And then we'll go out and build an alerting system for ourselves that can alert us if there's some sort of performance degradation on production. The next thing that we will do is to look at some of the things that we've learned at Yahoo, some of the wisdom. Now, this is by no means a comprehensive list. If you just search for Android performance on Google, you'll see tons and tons of tips and tricks. And I'm not going to get into everything. These are some of the things that we've learned that we thought were interesting. So let's jump in. So we kind of know what coldstart is, but let's look at how an application starts up. So a user comes in, a user taps on the application. So user taps on the application. You set up the UI. You probably have no content then. You likely at that point make a database call, get some data out, load it on your UI. You go out and make a network call and get the data and then show it on your UI then. So this is obviously an oversimplification of an application, but let's start with this. The other thing that we have to understand here is applications can start up in a lot of ways. So for instance, a user installs the app for the first time. You'd probably take the user through some sort of an onboarding flow. Now, do you want to spend a lot of time optimizing and automating around that? You probably won't. Likewise, there are notifications, deep links, and a bunch of other things. So let's be clear on what we want to automate. I'm going to talk about coldstart, but as I keep saying throughout, go back and figure out what you want to optimize. And also keep all the special cases in mind. If a user, say, opens up your app and the user is in the subway and you just say no network, you probably don't want to kill yourself trying to optimize that code flow as well. So just keep all these things in mind as you look at the next couple of snippets of code. So to talk about this whole thing, let's use a simple application that we've built up. What you see here is a list of companies that are trending on Yahoo Finance. So for some reason that we don't know, that we all would probably like to know, these companies are trending and users are showing a lot of interest in them. And this list keeps changing dynamically. So in the sample application, we have an application object, we have an activity object. We go out and we have an internal API where we can say, okay, give me a list of all the companies that are trending. We throw them on the screen. We get all the prices of these companies and put them up there. So let's use this as a base application as we talk about the whole thing. Going back to that flow that we were talking about, imagine you have a timer in your hand, right? So a user taps on the application icon. Android goes back, loads all your classes, looks through your manifest, finds your application activity, instantiates them. All that is in the system. You've still not executed any code of your own. And all this is possibly outside the realm of very simple optimizations. There are a couple of things you can do that we'll talk about later, but let's leave this out for now. Let's say we won't worry about this. Then your actual code starts executing. You've probably loaded up your application, then you go out and load your layout, and your layout is now loaded. And at this point, your app starts becoming interactive. So if you have to capture this point, if you were to keep track of the first line of code, the timestamp, and the timestamp now where everything's loaded, you will get some sense of how much time it takes for the app to become interactive. Likewise, you go on and load some data, so cache data. This might or might not be relevant to you. It's probably relevant to like an email application where it loads up all the emails that a user has locally stored and then goes out and gets more data. If you want this time, you again do the same thing. You have two timestamps. The first time you executed some code and system.now, and you just look at a difference. And likewise for fresh content. But again, so what do we mean by loading cache content and fresh content here? Again, I'll have to throw the ball back to you guys. You have to figure that out. Content for you guys is, it's very, very specific to your application. Find your most important pixel, what your most important pixel is. Say, okay, after I've loaded this, I'll say, all the fresh data that I need to load as a part of coldstart is loaded, and let's keep track of that. Let's spend a little bit of time looking at some of the code patterns that we use to capture all this. Before I don't have my notes, so this happens a little bit. So before we get into code patterns, till now what we've captured is actually our coldstart numbers, but we don't know where we are spending our time. The actual numbers, they don't let you do anything. You can't use that to optimize. If you, the way you would normally go about figuring this out is using the method tracer. You drop those 2 points, maybe the first line of application create to when your UI is loaded, and you get this sort of a visualization. It shows you, these are all the methods that you have. This is where you spend your time. But we're talking at the level of methods here, and it throws a lot of stuff at you. It's very difficult to figure it out. The bigger problem is that it really slows your application down. So while it gives you a good sense of where you're spending your time, you can't make much out of these numbers themselves. The third thing is, if we want to figure this out for users on production, you can't use this tool because it's slow and it's not meant to run on production. And also you can't hook this sort of a thing into your CI system. So there are a lot of problems with this. It helps very much when you're developing on your computer, but not beyond that. So we went out and we built something along the same lines. We've defined something called a phase. A phase is a section of a code that we find interesting. This could be things like initializing an SDK. This could be things like making a network call. This could be things like setting up your UI or performing a lot of operations. So any such thing that you think is interesting, you can drop these 2 lines of code before and after that phase. And we can build up a visualization that looks like this. So I'm sorry about the text. The text is a little difficult to read, but that's what my tool gives me. But I'll talk a little bit about this. You see 4 rows here, right? The 4 rows are the application object, the activity object, and the 2 network calls that we make. And what we're effectively, and the colors, the ugly colors that you see, they are the actual phases, the interesting snippets of code. So we do a little bit of activity loading, and then we go, do some analytics, and then our activity starts up, so on and so forth. So I wanted to set this up and show you guys how we actually find it useful. So the application that we wrote up, again, don't try to read into the actual text. I know it's not legible, but you see a bunch of bars, and you know that we're doing a little bit of work there. Can anybody find something very, find a very obvious optimization here? Okay.
Your fetch quotes line is way off to the right of your fetch tickers line.
Right, very good. Anything else?
There's a gap between the red and the green.
Yes. Yes. So excellent. All these are problems. This is why we think visualization is very useful. Instead of this, if I were to just throw like a spreadsheet of numbers at you, then it would be difficult. So we went on and we built this tool which helps us visualize all the phase information. I'll talk a little bit on how you can do that yourself. So check this out. This is what we did. So the fetch tickers call, it turns out that we're doing it really, really late. And rather, we could have done it really early. And now, sorry. So instead of starting the red box here, so instead of starting this box here, which kind of starts after your activity starts off, we start it here. So this actually starts in your application.onCreate somewhere. And because of this, on this particular run, we save about 300 milliseconds. And if you're talking about 2000 milliseconds, 300 milliseconds is a lot of time. So this, that's what visualization gives us. And now we'll finally look into some code that'll help us build these kind of tools and save all this sort of information. So we have a bunch of components, the application activity and the 2 network calls. And we have in the middle of the whole thing, I'm talking about code patterns here. The idea is not for you to take all this code back and write it yourself. So we have something called a coldstart register, which is a singleton object, and it has a stopwatch with it. Takes a stopwatch, and all these other classes, they keep reporting their state back to this machine. Think of this like a state machine. As the application moves through multiple states, this will keep maintaining the state. And finally, it learns that, okay, the UI is loaded up, everything that I need is in place, and then it'll go out and report all that data out. It'll do that on a network thread. It'll do that when it's probably connected to Wi-Fi. So, you won't be eating too much of your users' resources. Code patterns. So we have a stopwatch. This is the black icon in the middle. This is inspired by the timing logger class on Android, if any of you guys have used that. Does something very obvious. It records time. So whenever somebody says, okay, this event happened, it actually takes note of the time there. But then how do we take note of time? We have a bunch of options. We have elapsed real time, current time elapsed, uptime elapsed, and elapsed real time in nanos. So each of these clocks are different and they do different things. And some of them are suitable for tracking and things like this, and some of them are not. For instance, current time elapsed is not, because it's your wall clock. And as user moves, they change time zones and things like this, it moves around. So it doesn't work. Uptime elapsed doesn't work as well because it's not a wall clock, and it actually almost works well for us. But then when the system goes into deep sleep, this clock stops. So, probably not a very good clock to use. You can use elapsed real-time nanos, but then do you really need nano-level information? So I would think that elapsed real-time gives you milliseconds level information. That I would think would suffice, unless you're building a rocket. Okay, so moving on, we have a state machine. We use enums to represent all the states. We have a couple of states here. The application object just starts executing. The application object executed, and then the activity starts executing. The app becomes interactive. All the ticker-related information is loaded, and the code-related information is loaded. And the cold start register, the big box in the middle, sits like this. All these components, they report stuff. The first thing that it does is it immediately takes note of time at that point. The other thing it also knows what the definition of startup done is. So it keeps looking for that. And in our case, if all the tickers and codes are loaded, and actually there's a small bug here, even if the UI is loaded, then it says, okay, we've hit cold start, and then it reports everything. So a little bit of code about whatever I was talking about previously. You have your application on create. You say, okay, I've now hit the state, which is application on create started. I go out and do my work, and then I say, okay, I've now hit the state where all my code is loaded. Then you move on to your activity class. You again have your on create class, and then you say, okay, activity on create begin. You've hit the state, and then you go out and load your network. You do your network call. When you get all the interesting tickers back, a ticker is a company, by the way. When you get all your tickers back, you say, okay, now I've loaded all my tickers on the UI. So before that, we actually also have this method called show trending tickers, which loads everything onto the UI. And then you say, okay, everything loaded. The next thing, so parallelly, so this call happens on a worker thread, fetch trending tickers. And your UI thread goes back to on resume and say, okay, so the app is now interactive. I've loaded the UI. So this is how all the states keep moving. And on another side, so we've loaded all the companies. The next thing that we do is go out and actually start getting codes. And after we get all the codes, at this point we say, okay, so we've now updated our state. We've loaded that as well. So this is how we record all the numbers. This is like a code pattern that you could possibly use. I'll talk a little bit about how we capture phases. So now this is the fetch trending tickers is an interesting thing that we want to capture. We want to see how much time we spend there. So we add two blocks, one at the beginning and one at the end. All this information goes back to the stopwatch. Goes back to the stopwatch, and the stopwatch, again captures all the timestamps for that information. And finally, at the end, now we have the stopwatch has everything we need it to have, and we need to figure out a way to push it out. Where we have a simple reporter class that I'll talk about this a little more in detail later, but we have a reporter class that can be used by the stopwatch. It says report all the events. The reporter takes in based on which environment we are in, it sends it off to the right system. So now we have a definition. We've looked at some code patterns to actually capture all the numbers and info we need. Let's look at how we can visualize all this. So all the information needs to go somewhere, right? The system where everything can go and we can park all this data is a telemetry system. Telemetry is remotely observing a system to monitor its health. So I'm going to so at Yahoo, we have a very large scale telemetry system that was built in-house where all the numbers that we previously captured, we can send it off to this machine. And that internally takes everything and pipes it to Splunk, if you guys have heard of Splunk. And on Splunk, we can do all sorts of fancy analysis on how are you doing, are there any problems anywhere, is there a slowdown somewhere, etc. And what we will be talking about here is how you can build a small scale system of your own without having to invest much into it. So what telemetry basically needs to do is we have a lot of these phones out there. Everything needs to take all the information that we have and it keeps reporting it to this telemetry system. So, and after that, if I go back to the system and say, okay, aggregate everything and give me a cold start, it should be able to give me a median cold start, which is the metric that we thought we should capture. The other thing we wanted to do is it has all the phase information. So if I say, okay, just give me a sense of how all the devices are doing online, it goes out and for each of the phase, it tells me a median start and duration. So it says on median, this phase takes so much time and starts at this point. The phase visualizer that I was talking about previously would be really cool to have it here. So I'm going to briefly talk about how we build it in-house. It's a very simple tool. It's based for the most part on the Google visualization timeline tool, which is a pretty slick thing that the Google guys have written. So you take all the phase information that you have, you add it to this thing called the data table, add all the rows there and plop it into a chart table, a very simple snippet, and you'll see the visualization that we were looking at previously. So now imagine if you guys were to go back and build a very simple HTTP server that could support the kind of post that we were talking about previously and the get that we were talking about previously and just drop in this snippet on that telemetry server. Obviously, this is an oversimplification, but you could have your own telemetry service working in-house. So what can you do with a system of that sort, right? So I'm going to quickly talk about how we build a performance degradation alerting system. This is based on the telemetry service that we previously built. So the telemetry service sits in the middle. We use a clock. We have a cron job running on a machine that keeps going to this telemetry service and it keeps getting all the aggregate cold start information, regularly. At any point of time, if we've broken our definition of, good cold start or goal, basically. If we've not broken it, we go back and the cron job comes back later. If we've broken it, then we send out an alert. On our case, we use Slack. So alerts come to us on Slack whenever there's a problem. But you might just as well do anything else, email, text, pigeon, whatever you want. So all these slides, I'm going to put this up. I'll be sharing the slides for your reference. That's because I'm jumping through screens quickly. So now we have an alert. We know that something's wrong. What we do is go back to our telemetry system. And we ask for, there's a bug there. It should say get aggregate phases. We take all the phasing information. Let me do that again. Right. We take all this phasing information and we send it to Slack as well. So I'm sitting on my machine, I'm doing my thing. All of a sudden on Slack, I get a notification saying, there's something wrong on production. Things are slow, and here is how things are behaving on, the median behavior everywhere. So I get like a phase visualizer. And then we figure out if we can fix it remotely from where we are without having to push a patch. If we can, we are good. If we can't, then, somehow bad code got past us and it's on production now. So we have to figure out how to go back and fix it. So I'll take a second here and talk about what the definition of being able to fix it remotely is. One of the very big things that we've seen is that performance degradation usually happens, for the most part, because of server-induced latencies. So there's some server somewhere, there's some sort of a load balancing issue, and all of a sudden the latencies go up. And that will be very, very easy to visualize on this phase thing that we get on Slack. We'll immediately be able to say, for some reason, we can't fetch trending tickers very fast. The system seems to have slowed down. We go back to the backend team and tell them. So till now, you maybe had issues like metrics like latencies of all your backend calls being captured or not. But if you build something like this for yourself, you will have all that info. And if there is a problem of this nature, you can go back to your backend team and ask them to fix it for you. If there isn't, like I said, it means that bad code somehow got out and got onto production. So what we did was we went out and built our own setup to try and catch all these problems early on. So as a part of our CI, we've plugged something in where if there's ever some sort of a cold start regression of some sort, we catch it early on and try and fail the pull request. I'll talk very briefly about what such a system will look like, but the idea effectively, like I said, is catch regressions on your CI and don't let it go to production. Now, there's a little bit of a problem here because we usually work with populations. Cold start, you can't just run the app on your phone and say, okay, how much time does it take to start? Because there's a very big latency. There are a lot of latencies, in fact, and the biggest factor that introduces latencies usually is your API calls. So if you have two simultaneous runs of your app, the numbers will look very, very different. So the definition of a regression, instead of us not hitting our goal now, is some sort of an uptick in cold start instead of bad cold start. And our definition of an uptick is if there's an increase of cold start of more than a certain percentage, we consider that a regression. And the problem of variance still exists, right? So server latencies, like I said, introduces the biggest variance component. To do away with that, what we've done is introduce a local HTTP server which is running on the app. So we have a new a Gradle flavor where we just spin up like a local HTTP server in the app. It serves mock responses, and boom, the latency more or less comes down to 0 all the time. For that, so we've consolidated everything into like one Gradle task that we've written. I'll talk about it briefly again. As soon as you run this task, it gets your code, it builds it up, it takes a new flavor, builds it up, installs it on a phone, and starts the phone up. Then it gets the cold start information for that particular run, compares it to the previous run from a previous commit, compares them, and sees if there's some sort of an uptick. If there is, we'll try and fail the PR. This is what this will look like. So like I said, you have all your app code, and you now have a local HTTP server running. You hit the local HTTP server run, and you get all the information back to your cold start reporter, the class that we were looking at earlier. And now we have to get all this data back to the Gradle target, and we've used Stetho for that. So for those of you who don't know Stetho, it's a pretty cool tool built by Facebook. It does a lot of things, but one of the things it does is called dump app plugins or custom plugins. And that's like logcat for machine readable information. So we use that to like send this data back up to the Gradle task. And then, so we have to aid this, you need to be able to compare the cold start that comes from this run to the cold start that comes from a previous run. So what we do is for every commit, we take the local cold start number and just save it on like a local file. Now what this means is you'll have to run the test on the same machine all the time. If you guys are adventurous, you can go out and build your own simple HTTP server that, given like a commit SHA or like a branch or a tag, you could save all the cold start information. It would be pretty simple to do. So we go there and then we say, okay, get the cold start for the previous commit. And then we compare that to the current commit, like I said, using a threshold. A threshold is some sort of a percentage uptick. If there is some sort of a percentage uptick, then we fail the job. If things are okay, there's no performance uptick, then there's no problem. And then if there's no problem, we take this commit and cold start combination, this SHA and this particular cold start, and write it back to our local file. So by doing this, we've actually been able to reduce our cold start incidents on production by like a very large factor. We practically have no code going out that disrupts cold start. Because that part, if we are to say that if we don't have something of the sort, then it puts us in a bad situation because that code path becomes very, very fragile. We will not have a lot of scope in going out and trying to modify that piece. So because of this, we've kind of avoided that. There are a lot of moving parts here. I've briefly spoken about them. I won't touch upon all these things because they're fairly easy to build. Cold start history, we just use like a local file. But like I said, if you guys are adventurous, you can do something a little more sophisticated. Using Stetho, there's a lot of documentation on there. If you just go to facebook.com/stetho.git, you'll find everything there. Look for dump app. That's what'll get you what you need. I will talk very briefly about this. I'll show you what our code looks like. The idea is for you to go out and build something of your own again. So this is our build.gradle file. So for the local HTTP server, we've used nano HTTPD. It's a Java web server. It's one file, very fast, very simple, very straightforward. And now instead of the single Gradle flavor that we previously had, which is just the production flavor, simplification, we now have two flavors. One is production and one is cold start test. And in each of these flavors, we point to different HTTP servers. On production, we just go to our regular server. And on our new flavor, we instead go to 127.0.0.1. Now, the way we get our server started up is we've created a new application object in which we just plop in the HTTP server, which is very simple to do. You just plop that object in and say server.start, it starts up. You need to specify a port, by the way. So, and the next thing we do is whenever a network call comes in, we take this particular URI. We have some mock responses which are stored locally, and we just serve them up. So you guys this introduces a little bit of work here. It tends to be a little laborious because as you keep making network calls, as things change, you'll have to go back and get mock JSON. But then as a part of all the parser tests, you guys are likely already doing this. So it's just a matter of storing everything in one place and making it accessible to everything. We store it in our assets and we just serve it off our assets here. So these are some of the things that we've done at Yahoo to try and make sure that the app continues to start up fast without having to invest a lot of time in every cycle. I'll briefly talk about some of the things that we've learned as we went through this exercise, and we keep learning, obviously. The very first thing that we've learned is optimize your UI for startup. So I can tell you a little story here. If you guys have ever used the finance app, one of the things that it lets you do is create multiple lists of companies that you care for. For instance, you could have like a technology list. You could have, green energy stocks list. So people tend to usually create multiple lists. When they open up the app, we start by showing them a spinner, which can, select which list they want to view. And Android spinners are notorious. They give you all sorts of callbacks when you don't expect them, and sometimes you expect callbacks, you don't get them. It's documented. So because of this, we had a code model where everything was linear. We just wait for the spinner to give us a callback, and then we go on continuing. And this introduced, because of this, the nature of things being serial, we lost about 300 milliseconds in cold start. So what we did was we went back to the design phase. We took out the spinner, and we introduced another element which looks a little bit like a spinner but works very differently. So our UI actually changed, but then we regained those 300 milliseconds back. So always keep asking this question. The design is not fixed. The design has to help the user, and if the app is starting up slowly, you're not really helping the user. So make sure you ask that question. The next big thing is your APIs. Your APIs have to work well, they have to work for you. Are they fast? Do you have any numbers on how fast they are? Do you have latency information? If you don't have it, quite likely your backend team already does. Go back, ask them for the numbers. See what how that fits into your current cold start. If it's slow, maybe you should invest in that. The other thing that we've done is get something called a first page API build. Again, going back to Yahoo Finance, we had this API that we would make a call, and then it would give us a list of all the companies that the user cares for. And then we'd make another call, and then we'd get everything, all the price information. This was, making two calls is always bad. I'll talk about that in a little more time. But what we instead got them to do is build a single API which gives us both these pieces of information. Now, these kind of APIs look a little ugly because they're not RESTful. They give you two pieces of information which are probably not related very tightly, but then you gain from it. The other thing is you can look into enabling compression on your server side. On any modern web server, it's usually just including like a config element, a very simple thing. You don't have to change your code on the server or on the client, but it'll actually save you a lot of data going over the wire. And also, again, look at your caching policies. What kind of data are you serving? Are you serving news or mail or things like that, which won't change every second? I'm the tech lead for the Yahoo Finance Android application. And let's start with the show of hands here. So how many guys have applications on the Play Store? All right, not unexpected. Keep the hands up, keep the hands up. How many of you guys here think your apps start up fast? Okay. And, well, all right, I was going to ask if you guys are confident that as you keep iterating and adding more and more features. Okay, yeah. So I was going to ask if you people are confident that as you keep building, as you keep iterating. Not a part of it. So as you keep iterating, the app tends to stay fast. So that's what we're going to talk about today. So we're going to talk about how you can iterate fast, not worry about keeping the app, not concentrating on giving the app fast because you've automated everything. So you can continue doing whatever you're good at. Okay, so users want the app to be fast, right? They have a lot of choice. You need to convince them that it's actually worth their time. So 20% users, they expect the app to start up really fast. And after that, they're very quick to judge you guys. So if the app is slow, then that's a reflection on the performance of the company. And if I plug my thing in. So going forward after that, they don't hesitate, they're ruthless. They don't hesitate to actually uninstall the application if they think it's not doing all that well. So, it's a pretty big thing here. Now, we know they really want fast, but then, sorry, just give me a second, let me start this up. Yeah. Okay, but then what's fast enough? It's a very difficult question to answer, but there's a lot of research. And we've seen that 53% users actually drop off if a mobile page takes more than 3 seconds to load. So when I was doing a dry run and I ran this off people, they thought it was bullshit. So I actually put up the reference up there. And so this, it says something. The other thing is also that the top 40 apps on the Play Store, they actually take less than 2 seconds to load. So there's a trend here. Not probably a causation, but a little bit of a correlation. So we know they want fast, but if you actually go to a user and ask a user, you want an app to start off fast, but you know what actually fast is, then you might not actually be able to get a very crisp answer. Will they be okay if your application object is instantiated and starts up? The answer very likely is no, because you still don't have a UI. What about an activity? You have an activity. Imagine you did your set content view. You have your layout up there. Will that suffice? I would still say no, because you are looking at an empty screen, which probably doesn't add any value. Now, a lot of performance analysis services out there actually use a bunch of heuristics. Things like, are there spinners showing on the screen? Things like, has the activity loaded up? Or all the draw phase is done? Based on that, they say, okay, we've now cold started. But I don't think that suffices. So I would say that you actually need to load some data up, useful data, for the user to say, oh, okay, I tapped on this icon and I now have what I want. So let's look at a couple of applications to think about this a little more, right? We're looking at Facebook here. A user taps on the app opens up, the icons on top load up, and a little later the news feed loads up. So I'm sure Facebook would have done a lot of research. You should go talk to them. But I would think that the news feed has to load up before users say, okay, now I can see. I have what I need. Let's look at another application, Macy's. So you tap on the icon, a little bit of waiting, the hero loads up, the element on top. And then after a little bit, the sections on the bottom load up. Maybe it says that users care more for the hero on the top. Bear with me as we look at the last application. This is IMDb. It's a little more complicated. They load up 2 sections, and then they take their time to load the section in the middle. So, what's the takeaway here? The takeaway is it's very difficult to figure out what users want when the application starts up. And that's for you guys to decide. So you have to go figure out what your most important pixel on the screen is. The thing is, very likely you already know the answer to this question, because it's very likely baked into the design of your UI. So you have to talk to whoever it is, your VP, your CEO, your designer, and find out an answer to that question. Now, if you don't have an answer to that question, it's probably a little bit of time for you to go back and introspect. Figure out when your user taps on the application and the app comes up, what do they want first? So we're looking at the Yahoo Finance application here. We actually went through this whole process ourselves. Now, on the screen here, so a little bit of an intro about the application. You can open up the application. You can do a couple of things. You can look at the health of the financial markets. Here, we're looking at a section